So we talked a little bit about what integers are, but let me refresh your memory. Integers is going to be the set of numbers that's got all of these in it. So as you can see, the integers have all the whole numbers, 0, 1, 2, 3, 4, 5, up to infinity, but also the opposite of each whole number. You know, it's got 1, but it's also got -1. It's got 2, but it's also got -2. Notice there are no decimal numbers, no mixed numbers, fractional parts, decimal parts. Those are not going to be in the set we call integers. And I bring this up because what we're going to be talking about doing is adding integers. So we're going to be adding integers only. But I will tell you what we're learning about how to add these integers applies in general. It's not just to integers. It's just that we're going to focus on integers at first. But the same rules that we're going to learn apply whether you're adding decimal numbers, fractions, or whatever. Okay? But we're going to focus just on integers right now. Now, I guess a couple of things I'd like to point out. We're going to be doing problems like this. Now, you've done that problem, obviously, before. But this is adding integers. 6 is an integer, right? 8 is an integer, and we're adding them. Okay? But we also want to be able to do problems like this one. And problems like this one. Right? So we're going to broaden our horizons a little bit. So, and the way I want to do it is I want to start by giving you a rule for adding, okay? So here's the rule for adding. First of all, when you're adding, there's two cases you could be confronted with. Case 1 is where the two numbers you're adding have the same sign. Okay? And case 2 is where the two numbers you're adding have unlike signs. So I guess examples of same signs would be like this, 6 plus 8, they're both positive numbers. Or -6 plus -8, like this one. You're adding two negative numbers, right? And I guess this one in the middle here would be an example of case 2, where they're unlike signs. One of them's positive, one of them's negative. Now, if you think about it, if you're adding two numbers, aren't these the only two possibilities? They either have the same sign or they don't. So this is going to cover all of adding when you add two numbers. So when you have same signs, you're going to add the absolute values and keep the common sign. Now, what do I mean by that? Yes?
If it's like -6 and -8, if you do the absolute value of those, so it's 6 plus 8 and then 14.
Right. So that's adding the absolute values, the 6 plus the 8, gives you the 14. What about this last part? And keep the common sign. What does that tell us?
You keep the plus sign.
Well, now, the example you gave me was this one, right? -6 plus -8. What sign do these two numbers have in common?
Negative.
They're negatives. They're both negative. So, we're going to add the absolute values, just like you said, the 6 and the 8, because the absolute value of -6 is 6, and the absolute value of -8 is 8, and 6 plus 8 is 14. But should our answer be positive 14 or negative 14? Well, the second part of the rule says we keep the sign they had in common. So, they were both negatives, so the answer is going to be negative. Okay? Keep the common sign. Now, back to our old familiar problem, 6 plus 8, that's adding the same signs too, isn't it?
Yep.
So we're going to take the absolute values, 6 and 8, and add them up and get 14, but this time, what sign do they have in common?
Positive.
Positive, so it's going to be a positive answer, okay? See the difference? If you add two negative numbers, you're going to get a negative answer. If you add two positive numbers, you're going to get a positive answer. You agree? You understand that?
Sure.
So that's case one, where the two numbers you're adding have the same sign. Let's look at case two. What do you do in that case? You actually subtract the absolute values and keep the sign of the number with the biggest absolute value. Let's look at an example and see how it applies to that example. Let's say we were doing, -6 plus 8, okay? Clearly going to be case two, right? Because we have a negative number added with a positive number, unlike signs. Yes? Yeah, well, tell me what to do.
The absolute value of 6 is 6, and the absolute value of 8 is 8.
Right.
And then you subtract those 2.
All right, so you're gonna do 8 minus 6, right, which is 2,
And you're gonna get positive 2.
and it's gonna be positive because 8 had a bigger absolute value than -6, and 8 was positive. So our answer is going to be positive. That's right. So we take and subtract our absolute values. The absolute values are 6 and 8. We subtract 6 and 8. 8 minus 6 is 2. But it's positive because 8 had the biggest absolute value and it was positive. So when you have unlike signs, the number that has the biggest absolute value is going to determine what sign your answer gets. Yes, sir.
So what you're saying, what y'all are saying is, so like if it was -8 and positive 6, it would be -2.
Correct. Now let's do that one next, since you bring that one up. What if we did -8 plus 6? Well, it's going to work the same way. We're going to take our two absolute values, 8 and 6, and we're going to subtract them. But this time, the number that had the biggest absolute value was a negative number, so our answer is going to be negative. Yes? So again, when there's unlike signs, the number that has the biggest absolute value is going to determine whether our final answer is positive or negative. Make sense? Now, we need to look at these on a number line and get a visual for why these rules make sense. Okay? So let me draw a number line. And keep in mind when you're working problems and you kind of maybe get confused about what the rule said, it may be helpful to draw out or even just imagine a number line in your head and kind of get your thinking straight. So let's think about how this is going to work. Let's say we're going to do, -4 plus -2, okay? In other words, we're looking at case 1 up here, aren't we?
Yes, sir.
So here's the way I like to think about it. Here's -4, and that's the number we're going to start at. So I'm just going to put a dot right over -4, okay? Now, we're going to add to that a -2. Now let's get straight about something. If I'm on the number line somewhere, and I add a positive amount, which way am I going to move on the number line?
To the right.
Yes. So, does it make sense that if we were to add a negative amount, it would be just the opposite? Adding 2 is going to go 2 this way, but adding -2 is going to go 2 this way. In other words, adding a negative is a fancy way of saying that you're decreasing. So, we're adding a -2. We're going this direction 2 more units. 1, 2, and that of course puts us at -6. This equals -6. Does that make sense? So do you see that if you're adding 2 negative numbers, you're always going to start over here on the left side of 0, and then you're just going to go further that way. There's no possible way you can get anything but a negative answer. Does that make sense? Alright, let's look at one like case 2. This time, let's suppose we're going to do maybe 5 plus -3. So we're going to start at 5. That's the number right here. That's where we're starting. And then we're going to add to that a negative amount. Which way is that on the number line? Remember, adding a negative is a fancy way of saying we're decreasing. That's going to the left. How many to the left are we going to go? 3. So if I go 1, 2, 3, that leaves me right here at 2. Do you see why the number that has the biggest absolute value is going to determine whether you end up with a positive or a negative? See, we went 5 this way, but we only came back 3. So we had to end up on the positive side of the number line because the positive number had a bigger absolute value than the smaller number. And I guess one more example to make that even more clear. This time, let's make it -5 plus 3. This time we start at -5. But we're adding 3. Which way is that going to move us on the number line? To the right. If you increase by a positive amount, you're going to be moving to the right. But we're going to go 3 units. 1, 2, 3. That gets us to right here. But what number is this? -2, right. And again, because the -5 had a bigger absolute value than the 3, we went this way and we didn't come back as much as we had gone that way. So we end up with a negative number. Do you see why the rule says what it says about how you know what sign to put on your answer?
Yes, sir.
And I'll show you one more thing. Notice on this first one where we had same signs, we went to the left, and then we just kept going even further to the left. We went a distance and then added on even more distance. Add the absolute values. But notice where there's unlike signs, we went one way and then we backtrack and go back against where we had just come from. Subtract. That's why you subtract in those cases. Does that make sense?